We welcome you back to the final webinar of WeatherWorks Winter Preparation Series. My name is Nathan Wiles, lead meteorologist, and I'm happy to be joined today by our returning guest and chief meteorologist, Jim Sullivan. After what was a nice rebound in 2020 following a lull in the 2019 winter for many of us, we are now faced with a second-year La Niña that may have a bright outcome for snow lovers across the United States. While Jim takes you through the winter setup and regional forecasts, for those that are using a laptop or desktop computer, you may download a free copy of our national long-range forecast on the left side of your screen. Jim, the floor is yours.
All right, thank you, Nate. So as Nate kind of touched on, we have a La Niña again this winter, so we'll touch on what La Niña is and what that means. Not all La Niñas are created equally. Some are a lot colder and snowier than others, so we'll kind of discuss what drives those differences, and we'll put it all together along with some caveats and uncertainties and give you what our winter outlook is right now. So kind of want to break down what a seasonal forecast is. It is not the same thing as your day-to-day 7-day forecast that you might get on your phone or on TV or from WeatherWorks. We also do short-range forecasts here. So seasonal forecasts are a lot more general. We're looking more for, as opposed to, is it going to rain at 12 o'clock tomorrow? We're looking for, is it generally going to be a wet pattern, a dry pattern, warm, cold, etc. So it's less specific, but it still can certainly add value, both to snow removal. You know, maybe you're trying to figure out, should I order a lot of salt for this year or something? Or, you know, beyond WeatherWorks, you know, something like natural gas. People actually trade gas shares based on the long range forecast. So there is still some use, even though it is definitely a less specific forecast than what your day-to-day would be. So we'll jump right in. What is La Niña? La Niña occurs when trade winds intensify across the tropical Pacific, as in the bottom image here in this schematic, and that causes the waters to cool down. It's the opposite of El Nino. That's the top of that schematic, where the waters are warmer. So some recent La Niña winters was last year, 17-18, the winter of 16-17. And, you know, there have been actually quite a few La Niñas here in the last 15 years or so. And I'll go through them one by one here shortly, but these winters tend to be quite up and down. So there's kind of a common weather pattern where if you take all the La Niñas, blend them together, it kind of looks like this. So in a La Niña, we tend to have a dominant polar jet stream. That's the northern jet stream. It's cold to the north, mild to the south. And that tends to be stronger in La Niñas, with a weaker subtropical jet stream. That's the jet stream that runs across the southern US in winter and brings a lot of moisture. So that tends to be a little bit quieter. So it's a lot of times drier in the south in a La Niña, a lot of times colder in Western Canada into like the upper Midwest, where the cold air drops in a lot of times with a La Niña. And La Niñas tend to be active both across parts of the Pacific Northwest, where that stronger polar jet stream runs into the coast, and then also across parts of the Ohio Valley, southern Great Lakes, where the jet stream tends to round the corner. So that's kind of the typical La Niña weather pattern. And looking at all the La Niñas since 2000 and kind of blending them together, here's what the temperature on the left and precipitation on the right looks like. Again, this is all of them thrown together, but you can certainly see a similar underlying pattern, generally colder the Northwest, the Northern Rockies, into parts of the Midwest, milder across the South, and then across the East. And then in terms of precipitation, these La Niñas since 2000, again, follow the similar theme, very active across the Northwest, the Northern Rockies, and then across parts of the Ohio Valley, Great Lakes, and into New England, with drier conditions across the South. So again, I want to stress that this is kind of like when you take all the La Niñas with no consideration for anything else and throw them into kind of a blender. This is what they kind of spit out since 2000. So this is a very nice starting point, but as I'll detail at length here over the coming slides, it's definitely not a final ending point. Because if you'll recall last winter, it was brutally cold for a time in Texas, historically cold for a few days. It was rather snowy from like Pennsylvania and parts of New Jersey points north. So there can be exceptions, and even last year is a good example of you can get some deviations from this general pattern. So I want to briefly touch on NOAA's, or the Climate Prediction Center's, outlook, just because here at the office we have gotten a couple calls kind of asking why we differ. So this kind of goes back to what a seasonal outlook is. Their outlook is a general outlook for the 3-month period. So you see that orange on the map over the eastern US and implies that they're leaning towards a mild winter in those areas. But even if their forecast is correct, and I'll explain or weigh in and show our forecast a little later, even if their forecast is correct, you get some colder and warmer deviations from this. And I just want to point out that their maps actually kind of explicitly have like what the probabilities are and what they mean. So most of the East Coast is in that second shade of orange. That's a 40 to 50% chance of an above normal winter. So that still leaves 50 to 60% chances for a near normal or a colder than normal winter. And you can even see they kind of explicitly say that 40 to 50 that's leaning above, and then you get higher than that, and it's more likely. So there is still a fair amount of kind of uncertainty worked into their forecast. Again, they aren't explicitly predicting snow. And also, this is only a 3-month period, December 1st through the end of February. It can be cold and snowy in March, and that still counts towards your seasonal total, but it wouldn't get captured on this map. So their outlook looks a lot like kind of your typical La Nina. And again, it's worth noting, even if it's a mild winter, you'll get colder swings at times. And it's possible that there are some other flavors of La Nina that might emerge this winter. So let's start going through some of the different flavors of La Nina. And something big, it's going to be a repetitive theme here through this webinar, is the word blocking or high latitude blocking. So I thought about where I wanted to put this slide, and I figured I'd better put it here before it comes up in the subsequent slides. So high latitude blocking occurs when there's a big ridge in the jet stream in the higher latitudes, which causes the jet stream to buckle, and it sends cold air south. So on the left, you have an example of a winter that had a lot of blocking. It was the winter of 2010, 2011, I believe. And you can see big areas of blocking, big ridges in the jet stream near Alaska, near Greenland, and that resulted in a pretty cold and snowy winter for most of the United States. But then on the right, you have the winter of 2019, 2020. It's literally the exact opposite. No blocking in the pattern whatsoever. You have cold air or cold colors over Alaska and Greenland, and that signifies a jet stream that's very strong. It's very west to east moving. It's harder for it to bend and let that cold air come south. So a big difference between cold La Ninas and mild La Ninas, as you'll see, is if we get blocking or not. So let's go through some recent La Ninas just to kind of drive the point home of there are a lot of different flavors of La Nina. So the winter of 2007, 2008 was a La Nina. And this winter, there was not much blocking. You can see cold air blues on the left over Alaska and over Greenland. So this was a very prototypical La Nina winter. It was very cold across much of the western US, even into the Midwest, but it was mild from Texas and then over towards the East Coast and points north. It was very active. These are precipitation departures on the right, very active from parts of the Midwest through the northern Ohio Valley, southern Great Lakes into New England. So that's kind of one example, but here's the next winter, 2008, 2009. This winter had a little bit more blocking. You can see there are warm colors near Greenland, so a little ridge there. And you can see the warmer colors extending towards Alaska, so that ridging over the Pacific is nosing into Alaska. And that resulted in a colder winter across the eastern US than the prior year. So already a big difference there. And then here's the big one, the winter of 2010, 2011. This was a strong La Nina, but there was a lot of blocking near Alaska and near Greenland. It was a cold winter for most of the country. So at this point, hey, La Nina, maybe not so bad, although there are some examples that go the other way. So moving on, the next winter, 2011, 2012, almost the exact opposite. There was no blocking. Very, very cold over Alaska and over Greenland, and that kind of signified a jet stream that was very fast and stuck up over Canada most of the winter. And the result was a ton of red on the temperature map across most of the lower 48, especially the central and eastern portions of the country. Here's the winter of 2016, 2017. This was a La Nina. This winter tried. There was a little bit of blocking near Alaska at times, a little bit of blocking near Hudson Bay at times, but it was still a pretty mild winter. Still in general, not much blocking, a lot of blues at the high latitude there on the left, and then the resulting temperatures in the middle, pretty mild for most of the country. But it was a very active winter, so places like upstate New York still got plenty of snow this winter, even though it was relatively mild. Farther south was not quite as snowy as you would imagine. And then Here's another winter that goes the other way. 2017, 2018 had a lot of blocking over Alaska, the North Pole, and some blocking near Greenland, especially in the month of March. And that resulted in a fairly chilly winter for a good chunk of the central and eastern United States. And here's last winter. There was blocking near Greenland and over the North Pole for a decent chunk of last winter. It was a mixed signal. There wasn't a ton of blocking over Alaska. That's why it wasn't an extremely cold winter, even though it did snow in a lot of areas. So basically, those are the last, 6 or so La Niñas, and almost all of them look different. The underlying pattern for a La Niña is what we discussed earlier on, but there is a ton of year-to-year variability. So kind of the trick is not just saying we have La Niña, so it's going to be a mild winter on the East Coast. It's not quite that simple. It's kind of figuring out which one of these many flavors are we going to have. So I took a look at all the La Niñas since roughly 1980. So there's like about 7 or 8 years in each of these kind of sets that we're looking at now. And I kind of grouped them cold versus mild, or good versus bad. I'll let you decide what's good and what's bad, but you have the cold La Niñas on the left and the mild La Niñas on the right. And so you have the pattern, kind of that's the hemispheric view for each, and then the United States temperatures, that's the US map for each. So here's a look at the big difference between the cold and the mild La Niñas is that blocking. The cold La Niñas, they have blocking near Greenland, over the North Pole, and a lot of times into Alaska, whereas the mild La Niñas have the exact opposite. All the blue colors are focused over Alaska, the North Pole, and Greenland, and that signifies, again, a very strong west to east moving jet stream with cold air that struggles to dip south. And you can see the result in the United States temperatures. The cold La Niñas with blocking, they're much colder, especially over the eastern US. In fact, they're almost opposite patterns. So we can get a lot of different outcomes with La Niñas. Again, the NOAA's outlook kind of looks a lot like the typical La Niña, but you can get a lot of fluctuations or a lot of differences year to year, month to month in a La Niña. So just because we have a La Niña does not mean it won't snow. So obviously the big question you guys are all asking, and it's probably why you joined this webinar, is can we predict what flavor of La Niña we're going to have this winter? Is it going to be a cold La Niña with blocking and snow farther south into like the Ohio Valley and Mid-Atlantic? Or is it going to be a mild winter where all the snow is stuck into the like upper Midwest and maybe northern New England, upstate New York? So we looked through all these different La Niñas, and certain tendencies showed up. So the big key is we're trying to predict if there's going to be blocking this winter. If there is, decent odds we get some colder swings. If there's no blocking, it'll be a mighty struggle. So La Niña intensity plays a significant role, I think, in terms of if we have a colder or a milder winter in the United States. Stronger events tend to be milder in the United States. Where the La Niña is based, and I'll explain what that means in a minute, also plays a role. So where are the coldest waters across the Pacific? Some other patterns, including in the stratosphere, tend to be pretty good predictors for what flavor of La Niña we're going to get. And then there's other things that kind of emerge through the fall and winter, such as the polar vortex, a big buzzword here the last 5 or 10 years. So we can at least get a decent inkling of if this is going to lean towards a colder La Niña with blocking or a milder La Niña with much less snow potential. So here is this year's La Niña. It is currently a weak event, but it's approaching moderate intensity. And you can see the computer model projections of the intensity on the right. The general gist is maybe it gets a little bit stronger through the rest of the fall. And then that black line I drew, that is kind of like the midpoint of winter. And then after that, it looks like it'll start weakening into the spring. And you can see the different shades of blue here. The first shade of blue is a weak La Niña. That's where we are now. And the second shade of blue, that's a moderate. And some models get us to moderate intensity. And it's very chilly just below the surface across the Pacific right now. The waters just below the surface are decently colder. So I do think there is a little bit more room for this and to intensify towards moderate intensity through the rest of the fall. So we're looking at a weak to maybe a moderate La Niña this year. And what does that mean? So we're going to go back to kind of looking at these maps that we were looking at earlier. So I took all the La Niñas that we kind of talked about over the last few decades and kind of sorted them and looked at the resulting temperatures and patterns across the hemisphere, and more specifically the United States, based on the La Nina intensity. So you have your weak La Ninas on the left, going up towards your strong La Ninas on the right here. And then you have the hemispheric view, that's the same kind of pattern for across the hemisphere and the jet stream for the whole winter. And then on the bottom, you just have United States temperatures. So the weak La Ninas are the coldest La Ninas in general across the United States. There's in the weak La Nina, you can see a fair amount of blocking, both near Greenland and to some extent near Alaska. And that results in colder conditions across a good chunk of the United States. Moderate La Ninas, you start going the other way. A lot of moderate La Ninas still have a fair amount of blocking, especially near Greenland. So just because if it sneaks to moderate La Nina as opposed to staying just under that threshold, it's not going to drastically change things. Moderate La Ninas do tend to have still some blocking near Greenland, but you can see the blues sinking into more of Alaska. So this starts kind of transitioning more towards that classic La Nina look, where the cold is focused over like the Rockies and it's mild across the south and east. It's not hopeless, but it's starting to trend that way. And then your strong La Ninas, these are your classic. This is where you get your classic look of cold air focused across Western Canada, the northwestern United States, and mild across the rest of the lower 48. Those are your strong La Ninas. So this winter looks like it's going to be somewhere between a weak and a moderate. So again, early on, we'll look at a few other things, but there's some hope at least. And this is a study done by I believe it was published on the Climate Prediction Center's website, of looking at snow in varying La Ninas. So you have weak La Ninas on the left, and if it's blue, that's more snow than normal. If it's kind of tan or brown, that's less snow than normal. And then you have your strong La Ninas on the right. And clearly, the weak La Ninas are a lot snowier across the Midwest, the Great Lakes, and even parts of the Northeast compared to the strong La Ninas, where there's a lot of tan and brown on the map from parts of the Ohio Valley into the Mid-Atlantic, even parts of New England. So again, it helps that we're not looking at a strong La Nina this year. So moving on from La Nina intensity. So again, we'll go back a couple slides. We're looking at a weak to moderate, which again is not hopeless for getting some blocking and some cold air. Let's move on to where the La Nina is focused. So if for those of you who watched our webinar last fall, I showed the same schematic. It still applies this year. It's from a research paper. And they identified two distinct types of La Ninas. They identified a east-based La Nina, where the event is focused closer to South America. The coolest water is focused near South America. And then they identified a more central Pacific-based La Nina, where the coolest water is focused closer to the international date line. So the question is, what is this year's La Nina going to be? Last year was kind of in between. It wasn't firmly Central Pacific or Eastern Pacific. This year is kind of similar. So I outlined a few different boxes here. This year, the waters are cooling pretty nicely right off the South American coast, so that would kind of point towards an Eastern-based event. But on the other hand, there has been a fair amount of cooling near the international dateline. There's a pretty good tongue of cooler waters there that would point more towards maybe a Central Pacific-based event. And then that middle box, I outlined where the very coolest waters are, and I also highlighted 150 degrees longitude. Basically, the paper found that the Eastern-based events, the strongest cooling is focused east of 150 west. So this year, like last year, there are some characteristics of both a Central Pacific event and Eastern Pacific event. I think it's leaning a little more Eastern Pacific than Central, and that's going to be very important. I'll show you why in probably a slide or two. So with that in mind, same thing we just did with La Nina intensity, kind of sorting all the La Ninas we have over the last few decades into Central Pacific La Ninas, Eastern Pacific La Ninas, or kind of mixed events. So clearly it is the Central Pacific La Ninas that pose a risk to have less blocking and are milder looking. So that's your classic La Nina look, where it's mild across most of the southern and eastern US. But if you look, the hybrid events tend to have more blocking, especially near Greenland, and they aren't as mild. Again, it's not extremely cold because it's kind of in between, but it's not as hopeless for cold potential as those Central Pacific-based events. And then you have your East Pacific La Ninas on the right, and those have the most blocking both near Greenland and Alaska, and they are the coldest across the central and eastern United States. So again, we're looking at either a mixed or maybe leaning Eastern Pacific-based La Nina for this winter. So again, right now there's a couple things already pointing to this maybe being a more beneficial flavor of La Nina for those of you who want cold and snow. And I know not everyone watching this wants cold and snow, but certain people, they certainly need it to make their businesses go round if they remove snow or maybe run a ski resort. So kind of moving from the water all the way up to the stratosphere. So the stratosphere is the second level of the atmosphere. We live at ground level in the troposphere, and most of the weather occurs in the troposphere. The next level up is the stratosphere, and in winter, the troposphere and stratosphere can interact. They don't in the summer, but they can in the winter. So what this is looking at is this is showing you a wind pattern in the stratosphere since 1980. And what I want you to focus on is how there are kind of so the golden colors, those are westerly winds in the stratosphere. So strong westerly winds in the stratosphere, they can kind of promote a stronger west to east jet stream with less blocking. Whereas the blues or the greens, the cooler colors, those are easterly winds in the stratosphere, and those can promote the opposite. Those can promote a wavier jet stream or blocking. So again, the colder La Niñas have blocking. So, and the pattern that has been pretty clearly established here is every 2 or so years, easterly winds descend and then westerly winds descend and so on and so forth. It's a pretty regular pattern until this decade or last decade, where a couple of different times that was interrupted. But in general, it's a pretty regular pattern. And looking at this winter, the easterly winds are descending through the stratosphere. So, we're going left to right from 2019 through 2021. 2021's on the right, and you can see the blue colors working their way down this year. And we're definitely going to have easterly winds descending through the stratosphere this winter. So at the very surface, that does argue for a little more blocking, and I'll show you some graphics here in a minute that really help drive that home, I think. So this winter's QBO, we do have so this phenomenon, this kind of every couple years things, or every couple year kind of westerly winds descend and easterly winds descend. It's an oscillation. It's called the quasi-biennial oscillation. The QBO is what it stands for. So that's what I mean by QBO. So we have easterly winds propagating downward through the stratosphere this year, which can increase the potential for blocking patterns. So what we did was we took other weak to moderate La Niñas and sorted them by QBO. And I believe that's this slide. It is. So years on the left. So again, this year we have easterly winds descending through the stratosphere. Those are the years on the right with a similar QBO. And then years on the left are weak to moderate La Niñas with opposite QBO. So again, these are focusing on weak to moderate La Niñas, which tend to be the colder flavors of La Nina anyways. And you can see when you sort them by the QBO, there is a huge difference. The years with an opposite QBO, where the westerlies are descending through the stratosphere, those have very little blocking. Whereas the La Niñas with a similar QBO, where the easterly winds are descending, those have a lot more blocking and are a lot colder overall for the United States temperature. So this is yet another thing that suggests that we may have the flavor of La Nina this year that gives us a colder outcome, especially across the central and eastern United States. So what the QBO really kind of affects most directly is the polar vortex. This is something that develops every year in the stratosphere, beginning in the fall, and then it dissipates in the spring. When the polar vortex is very strong, it tends to point to a lack of blocking in the troposphere. So the winter of 2019-2020, Nate mentioned it at the top of the webinar, it did not snow much in a large portion of the country. That was a record strong or near record strong polar vortex. So it can be very important, and it can shut a winter down if it goes the wrong way. Whereas last year, the polar vortex was very weak in the middle of winter. So that historic cold snap in Texas, the flurry of winter storms from the Midwest into most of the Northeast, along with some shots of colder air, that occurred when the polar vortex was weak last winter. So this is a pretty important piece to the puzzle, trying to figure out, is the polar vortex going to be stronger or weaker this winter? So this is an image of it very strong in early 2020. It was sitting right over the North Pole, and it was very hard for this pattern to break. So all the cold stayed locked up that winter. So here's more graphically that polar vortex influence. So on the left, you have the last like 15 or so winters that had a strong polar vortex. This is ignoring La Nina, El Nino, everything else. This is just sorted by polar vortex. And those years with a strong polar vortex, you see all those cold colors across the high latitudes near the North Pole, all the warm colors across the US. They tend to be very mild winters with no blocking. Weak polar vortex winters, this includes last winter, they are pretty much the opposite. You have warm colors over Alaska and Greenland, which suggests blocking patterns, and you have a much less mild look across the continental United States. And here's those same winters just sorted by United States temperature, something it's a little bit easier to see. The strong polar vortex winters, they tend to be very mild winters here across the lower 48. The weak polar vortex winters, you can get some more variability. So not the end all be all, but it's a pretty important factor, trying to figure out when we're predicting the winter, if it's going to be a strong polar vortex winter or a weak polar vortex winter. So some things we can use to try to predict the polar vortex strength in the fall. Now, one is the tropical water temperatures, El Nino, La Nina, also where the warmer waters in the Indian Ocean are located, because those are very warm waters that can really influence the pattern as well. Sunspots have been shown to impact polar vortex intensity. Usually when the sunspots are higher, it tends to lead to a stronger polar vortex, all else being equal. The QBO is another important factor because the polar vortex is in the stratosphere. The QBO is the stratosphere, so they definitely impact one another. And then there's intraseasonal forcings. These are things that aren't quite predictable until maybe 2 to 4 weeks in advance. So everything on this chart except for intraseasonal forcing, that can be predicted now in the fall. And how do these factors look for this winter? So La Nina on its own does tend to promote a stronger polar vortex. And this is a weak to moderate La Nina. The Indian Ocean, it's close to a wash at this point, but the warmest waters are close to Australia or Indonesia, which does favor a weaker polar vortex. The pattern itself is kind of weak, but it's there. The solar cycle, we're coming out of a solar minimum, so that still supports a weak polar vortex, but in a year or two, it probably won't. But this winter, it does. And the QBO right now, with those easterly winds working their way down this winter, strongly supports a weak polar vortex. So what the intraseasonal forcing does will probably help determine how this winter goes. However, beyond that, everything outside of a La Nina does point to a decent potential for a weak polar vortex this winter, which again is, if you want cold and snow, you don't want a strong polar vortex in general. So any early clues? This is a look at the European model ensemble. It's basically the Europeans run a forecast model out days, weeks, in this case, several weeks in advance. They have a seasonal model as well. And this is its prediction of polar vortex strength through early December. So it's actually quite weak right now at the end of October. It's going to rebound into mid-November, but a lot of spread starts developing within the model farther out in time, which is very common. That's why it's very difficult to give you day-to-day predictions farther in advance. But a lot of members do have very strong weakenings of the vortex. So the red is kind of normal, and then the blue is the model projection. So all the little blue lines, those are individual members within the European model ensemble. And there are a lot of members that have very weak polar vortexes into December. So, well, this is something we're going to watch very closely heading into November. Which way does it go? Do we follow the members that keep it stronger into December, or do we follow the members that get it weaker into December? That could tell us a lot about how December and maybe the first half of January play out. If we have a weaker polar vortex like some of these members have, we're probably looking at a very cold start to the winter in December into early January. So kind of taking a step back, factoring in all the factors that we've discussed here over the last 15 or 20 minutes, along with some other things, we looked for years that had as many similarities to this year as possible. So obviously starting with La Nina was a big thing. We also looked at the QBO, the Indian Ocean, sunspot cycles, and also what the weather pattern's been doing through the summer and fall. And some recent analogs and some top analogs are listed here. So last winter's a decent analog. I think the winter of 2017 and 2018 might be a very good analog. And if you remember that year, it was very cold in most of the central and eastern US around the holidays. December was a cold month. But then for a while, later January through February, it got quite warm, especially on the East Coast. And then in March, winter returned. There were like 4 or 5 nor'easters on the East Coast, and it was a very rocky start to spring that year. And as you can see, some other years listed, but here's the pattern for the winter. When we take all those analogs and kind of blend them together, there's a nice ridge off the west coast into Alaska. So the analogs do have some blocking over Alaska and Greenland. So the analogs are not hopeless. There are some up and down winters in here, like 2007, 2008, as we discussed, wasn't an extremely cold winter. 96, 97 was very up and down. So these analogs are certainly not cold and snowy through and through, and neither was 17, 18. But they certainly have windows of blocking and cold and snow potential. And here is kind of the progression through the season when looking at the analogs. So here's what they do early in winter, like November through December. The analogs have a ton of blocking across the northern Pacific into Alaska with a nice ridge on the west coast of the US, blocking over Greenland. And this would be a very cold pattern across the central and eastern US to start the winter. And it would be a pattern that could snow even along the East Coast. However, moving into midwinter, the analogs back off on the blocking in midwinter. And this is a classic thing we see in La Nina. A lot of the rule of thumb with La Nina is December is probably colder compared to February. Last year was an exception, but that's the general rule of thumb. And our analogs certainly bear that out. A more classic La Nina pattern. So, there aren't blues over Alaska and Greenland in midwinter, so it's not like there won't be any blocking whatsoever, but we'll probably see the blocking back off for several weeks in the middle of winter at some point January into February. And what that would do is that would allow the southern and eastern US to trend milder. It would cause the cold to pull back a little bit towards the Rockies, the upper Midwest. It would probably shift the storm track north, although it would probably be pretty active along that temperature gradient from the Ohio Valley into the Great Lakes in New England. But that would support maybe a quick start to winter, later November into December, followed by a more up and down, somewhat milder middle portion of the winter. Again, January, February are the coldest months of the year. So even if it's a kind of mild pattern, it can still snow or you can still see some icy weather in January and February, but there is definitely a chance that winter relaxes, especially farther south for a few weeks in the middle of the season. And then the analogs bring it back in March. And those of you who remember the winter of 2017, 2018, the most impactful part of that winter in the Northeast was March when you had all those nor'easters. And a lot of our other analogs have something similar. Blocking returns, especially near Greenland in March, perhaps into April, and maybe causes you to get one more opportunity for snow. And if you think back to the last several years, a lot of recent Marches have had notable snow in parts of the Midwest, Great Lakes, Northeast, even the Mid-Atlantic. So March is still very much a month where you can get some snow. And it's distinctly possible that this is a year where that happens. So kind of before I show you our maps for our winter outlook as a whole, I want to briefly touch on the pattern now, the end of October into early November. So this is a loop of the same European model ensemble. It's the shorter range version of that model through early November. So note at the start of the loop, the jet stream is slamming into the West Coast, and that's evident by all the blues. And if you guys have been paying attention, there's been heavy mountain snow out there. There's been a lot of rain and into parts of Lake California where they need it. But the Pacific jet stream slamming into the West Coast is a mild pattern. So that's why we have gotten, a significant coastal storm this week along the East Coast, but it's been all rain. It helps that it's still late October, but it's been very mild leading up to it. However, note how into early November that switches. we get a ridge to pop on the west coast, all those warm colors, and that will allow us to get a more polar shot of air early in November. We'll see if it snows anywhere with it. It's possible maybe from parts of the Great Lakes into like the interior Northeast, especially the higher terrain. So a big pattern change coming here just over the next week. But note how at the end of the loop, those blues start getting close to the west coast again. So I think we're going to get a nice cool down here early November. We might get some more Pacific influence into mid-November that would warm us up temporarily. But as I go to the next slide, this is just a look at the jet stream from the GFS ensemble. It's just another forecast model. So I'll let it start over. Note how early on in the loop, the jet stream is slamming into the west coast. So that's right now. But that quickly backs off into early November, and we get our cool down. However, you can kind of see the next surge of Pacific influence later in the loop. And then looking towards Asia, I'll let it loop through one more time. At the end of the loop, the jet stream is really kind of firing up over Eastern Asia into the Western Pacific at the end of the loop. That's heading into mid-November. And I think that is the sign of the next pattern change. It might be the bigger pattern change that leads to a much colder trend across a good portion of the country, including the central and eastern US. I think that maybe comes Thanksgiving week or maybe the very beginning of December. So I think we're looking at an up and down November. I think we get a big change towards the end of the month, though, and that carries into December. So with that said, here is our overall temperature and snowfall outlook for the lower 48 for this winter. So again, we are leaning towards a slightly colder flavor of La Niña, if you haven't picked up the drift so far. Again, kind of a middle ground because it is a weak to moderate event, and it's not a Eastern Pacific event solely. It's kind of more of a hybrid. So we aren't quite as cold with our outlook as some of those coldest sets of years were, but we do definitely expect some blocking this winter. We think it'll be quite cold across the northern Rockies, the upper Midwest. That will frequently work its way towards the East Coast, especially farther north. However, there will be milder air lurking to the south, so I think at times, especially in the middle of winter, that does work north at times. And then snowfall on the right. It's already been pretty active in the Pacific Northwest, the northern Rockies this fall. That should continue this winter, so they'll probably get a fair amount of snow up there. And then the other active area is from parts of the Midwest, Great Lakes, Ohio Valley into New England, where it should be cold enough. There will be a nice temperature gradient. You'll see frequent systems, so there's probably going to be a fair amount of snow. Heading into the mid-Atlantic, I think New York City has a decent shot at getting a bit more snow than normal. It will all come down to the blocking. Philadelphia kind of right on the fence. If there's a lot of blocking and it's a cold winter, definitely a shot. Philly comes in with a little more snow than normal. But they're more on the fence. And then heading south towards DC and Richmond, I think there are opportunities for cold and snow. I think the Southeast Ridge, as we call it, battles back at times and brings milder conditions. So we're leaning a little bit lower on snowfall down there, but certainly still think that you'll have some bouts of wintry weather this year. And then into the Southwest, probably a lot less mountain snow than normal, unfortunately. Big drought out west. I think that'll improve some farther north, but towards the Four Corners, probably not much drought improvement as it looks now. And these are kind of snowfall confidence boxes, if you will. So how we created these were, we took from the last 30 years, what these boxes are the low box is kind of like well below normal, the high box is above normal, the middle box is near normal. And over the last 30 years, 1 out of every 3 winters lands in each of these boxes on average. So climatologically, these numbers all should be 33%. So you can kind of see where we deviated above or below that and where we're favoring slightly more or less snow than normal. Our alert clients who got our full winter outlook a couple weeks ago, we obviously did this for a lot more cities. But this is just a nice sampling from the East Coast to the Midwest out to the West Coast of kind of how we're leaning. And it shows the probabilistic nature of things. So Boston, we feel pretty good that they'll get a fair amount of snow this winter, either near or above normal, but there is a non-zero chance that they still end up below normal. Certainly time for things to change, but this is where we are right now. And this does it for this webinar. So for alert clients of ours, stay informed through the season. We have a product called Winter Risk, both in the Mid-Atlantic and Northeast and in parts of the Midwest, where we kind of break down the long-range outlook over the coming weeks and even months. And this is updated multiple times per week through the season. So, you know, kind of laid out our preseason thoughts now, and we'll tell you how that changes through the season. And also, to our forecast and alert clients, we will send a mid-season winter forecast update in January. We've done that the last couple years. We'll do it again this year and let you know where we've been and if anything's changing. So that does it. Thank you very much for joining us today. And if you have any questions about the forecast or long range, please direct that to me at jsullivan@weatherworksinc.com. If you have a question more related to sales, maybe if you're curious to maybe see a demo of Winter Risk, you can send that over to sales@weatherworksinc.com. All right, thank you guys very much.